Newton's first law of motion. This law states that if there is no force acting on an object, the object will remain either be at its rest or at its constant velocity in a straight line. So Newton's first law of motion states that if there is no force acting on an object, the object will remain either be at its rest or at its constant velocity in a straight line. So what does this principle want to tell us? Tikuyenera tidziwe chani ku Newton's first law of motion? Tikuyenera tidziwoneza kuti ngati palibe force iliyonse, if we have an object, we have an object which is at rest. Tikati at rest ndo chinthu choti sichikuyenda. If we have an object which is at rest, and then there is no another external force which is applied to this object will remain at rest. And if we have an object which is moving, uniformly moving in a straight line, and there is no any force applied to that object, the object will remain moving in that uniform movement if there is no any other external force applied to it. That's what Newton's first law of motion imene kunena. Ngati object sina pangidwa applied force ina iliyonse ikhala mene lilimo. So we are saying every body preserves its state of rest or uniform motion unless the external force is applied on them. Chinthu china chilichonse chimakhala mmene chilili. Komano chimakhala mmene chilili pokapoka force ina yake pangidwa apply pa ichocho. For example, if you have a stone resting on the floor, if that stone is not applied with any other force, the stone will remain there. But when you go and apply force on that, chipeze oni mwala uja ndi pamene utapeze kuti wayenda. Koma ngati supanga apply force inaliyonse ukhala mmene ulilimo. Ngati chinthu chikuyenda with a uniform velocity, ngati utapange pa apply force imapeza kuti chinthu chajamba kuyenda mwachanga. Why? You have applied an external force. So that one is zimene Newton's first law of motion ikutiuza. Now let's see implications of the first Newton's law of motion. So the law defines the force which changes the state of motion of the body. Law yathu ya Newton's first law of motion inafotokoza zokhudza na force imene masintha kayendedwe ka chinthu ngakhale inali pa rest kapena uchipanga kuti chambe kuyenda. Matter has inbuilt resistance or inertia. Law iso inatiuzoneza kuti matter inaliyonse ili ndi inbuilt resistance, ngati imakhangati ili ndi kutsutsana kwina kwake, ngati reluctance makani ena ake amene ali mkatikati mwa iwo amene amatchedwa kuti inertia. About inertia timvetsetsa kutsogoloku kuti imapanga zotani. The force is at equilibrium when the resultant force is zero. So we are saying the force of the force applied to an object is going to be at equilibrium when the resultant force is equal to zero. Resultant force is like the force you are applying to an object. So the force you are applying to an object imakhaza kuti yalowa mu object jandimira pamene object jambe kuyenda. So the force becomes to at equilibrium when that resultant force is zero. Now let's see mass and inertia. Remember inertia tinaifotokoza kuti ndi ngati inbuilt resistance of an object. Kapena zoti this is the reluctance of an object to move. Reluctance ngati kanga kuti makani kuti chinthu chachita chiyende. Pamene mass, we already know what is the mass kalemedwe ka chinthu. So we are going to see this in details. So we are saying mass is the amount of matter in a substance. Amount of matters in a substance. If in a substance you have a lot of matters, it means each mass will be big. But when the matter of in that substance in a small amount, then the mass will be what? Will be small as well. Whereby inertia is the reluctance of a body to change its state of motion. Reluctance of a body to change its state of motion. Zonatu zonoziyani zilingatundezo kuti ndimadhana amene chinthu china chake chimapanga kuti chisinthe kuyenda kwake. Reluctance. So when we say reluctance, it's the inertia. So the inertia when an object having a lot of mass ngati kuti ndicholemera kwambiri inertia yake so imakhala yayikulu, ndicholemera pang'ono inertia yake so imakhala yaying'ono. So that's the definition of mass and inertia. Now Newton's first law of motion, we come up with some other subtopic, that is momentum. We need to know what a momentum is. So we are saying momentum is defined as the product of mass and the velocity of a body. Momentum is the product of mass and the velocity of a body. Kalemeredwe ndi mmene chinthu chikuyendera, imeneyo imachedwa momentum. Mwina anthu azina madabu anthu oforo kuzonera chinthu chili ndi momentum yayikulu. Kumazifunsa, what does the momentum mean? Momentum is when something having a big, or I should say yes, a higher momentum, it means mass yake ndi yayikulu komanso velocity yake ndi yayikulu. Mukozo kuvomerezana nani unezoti chinthu chimene chili ndi mass yochuluka chimayenda so mwachangu ngati chinthu chija wachipanga kuti chiyende. Why? It's because that is momentum which is having. So when it is having a high velocity and a big mass, then there you are going to have high momentum. But momentum is the product of mass and the velocity of a body. So it has a formula, mathematical expression, whereby we are saying momentum is equal to mv. So mv, we are saying where m is a mass and v is the velocity. Momentum is a vector quantity. So in form 3 munagambirana munaphunzira zokudzana what is the scalar quantity and a vector quantity. For recap, we discuss I know pofuna ngokumbutsana mukudzioneza kuti scalar quantity is the quantity which have only magnitude. That's a scalar quantity, a quantity which has only magnitude, whereby vector quantity is the quantity which have both magnitude and direction. So chinthu chimene chili ndi magnitude chabe ngokhala size chabe kuti iyi size yake ndi yakuti kalemero kalijeni yes its magnitude ndi yakuti kakulidwe kwake ndi kakuti kosalozera direction imene chikulowera imene ndi scalar quantity, pamene vector quantity imakamba za mulingo wa chinthucho komanso kumene chikulowera. So momentum is an example of vector quantity. So when we are saying momentum is a vector quantity, it means when you calculate a momentum, that is a mass times velocity, you need to show kuneza kuti direction yake imene momentum an object imalowera ndi kutiko. So the direction of momentum is the same as that of velocity. If you have identified the direction of the velocity, it means that direction ndi imene so momentum ikulowera. So the SI unit of momentum is kg meter per second. We got an example. Imene kuti a car of a mass 600 kg moves with a velocity of 40 meters per second. Calculate the momentum of a car. You can pause the video and try to solve the problem so that you should compare ndi yankho imene neyo ndizapeze. Ndi yankho imene neyo ababa nditapeze. So we are saying momentum is equal to mass times velocity. Ngati mera kambirana kale formula yopezera momentum. So we are just substituting. Pamene pali mass tikuyikapo 600 kg, pamene pali velocity tikuyikapo 40 meters per second. With multiplication tikuonetsapo 24. Answer yathu tikarayimusa 600 kg times 40 meters per second. Answer yathu inapezeka ndi 24,000 kg meter per second in the direction of velocity. So apa angoneza in the direction of velocity because they didn't specify kuti velocity ya object yathu mu question imalowera kutiko. Koma chikana panga specify ndoti bwezira chula direction yo. We got an example number 2. Imene kuti a body A of mass 40 kg moves to the left with a velocity of 7 meters per second. Another body B of a mass 7 kg moves to the right with a velocity of 6 meters per second. We got two bodies here, body A and body B. Imene body A ikulowera kumazere, body B ikulowera kuchani kumanja. So question A ikuneza kuti calculate momentum of body A and B. So when they say calculate of momentum of body A and B, it means you should calculate a momentum of A and momentum of B separately. So we are saying solution, that is momentum run its formula yathu, momentum is equal to mass times velocity. And then let's see a momentum of A. Momentum ya A ikhala chani? Tingotenga momentum ya A ndio tingotenga mass ya A yo ndi kumene ndi velocity yake. So isi 40 kg times 7 meters per second imene ndi 28 kg meters per second. Now momentum of B. Momentum of B is equal to 7 kg times 6 meters per second. Immediately 42 kg meter per second. Imeneyo dia B. Now, question B, I would calculate the total momentum of A and B. Now here, they have included the word total. So if they say total, it means you should calculate a momentum as zinthu zoma bodo sewa ndi chinthu chimodzi there in system. Momentum yawo mukayiphatikiza ingakhale yorani. So here, the first thing I need to tell you here is you need to remember that the momentum is a vector quantity. So a vector quantity imakhala ndi direction. Ukangosintha direction ya vector quantity, sign iso imasintha ya magnitude yake. Ngati nali ya positive imakhala negative. Ngati nali negative imakhala positive. So here we are saying since the bodies move in different directions, one has a negative sign and the other one is positive. Tunezo chifukwa zinthu zikuyenda mu direction osiyana, ina yakhala ya positive, ina ya negative. Kwa mafunso nkumati imekhala ya positive ndiri, imekhala ya negative ndiri. Easy tikupanga pokapo pamene tikupanga tikusolva zonse ziwiri pakamodzi. Mukozoona kumambiri uko kumene masolva problem question A sinina upange za negative kapena positive. Koma apo ifota nezo tipange total timamene mapangano ligadi kuti ikhala ya positive ya negative. So imene kulowera kumazere ndi imekhala ya negative, imene kupita kumanja ikhala ya positive. So here we are saying negative A plus B is equal to negative 28 kg meter per second plus 42 kg meter per second. So ya A raipasa negative chifukwa ino zoti kupita kumazere zikataimusana yankho yathu ikupezeka kuti ndi 14 kg meter per second to the right hand side. So the question can be, why is this momentum is towards right hand side? Why sinapita ku left hand side ifo yani chifukwa chonena kuti ku right hand side ndi kumene kuli momentum yayikulu. So momentum yayikulu ikaphatikizana ndi yaying'ono ikhasula yaying'onoyo yayikulu ikula mphamvu ndizikanga kuti yaying'ono ikungolowerano ikutsatirano kumene yayikulu ikutani ikupita. So zingata papa body A ndi body B, body A idzikoka body A. That's why yakhasulana momentum yake abwera 14 kg meter per second. Now let's see what is an impulse. From Newton's first law of motion, timafunika kuti impulse ndi chani. So we're saying impulse is the product produced by a force that acts on an object for a very short time. If you are applying a force on an object for a short time, it means pamene popo kupangapo impulse. Impulse is only produced when the force is applied on an object for a short time. So that's impulse. So if you can define impulse as the product of force times time. Like I should say, we can define impulse as a product of force and time. That's what I was saying. Defined as the product of force and time. So impulse is equal to force, immediately F times time, immediately T. The SI unit of impulse is the Newton second. Newton second. Why are we having Newton second? For the force SI unit again Newton, time SI unit again second. Impulse produces a change in the momentum of the object. So we are saying impulse produces a change in momentum of the object. The momentum of the object can be changed with an impulse. Remember, by impulse, I'm accounted by force. So if you are applying a force on an object, zonto zoti chinthu chidzienda. Pamene chikuenda pa ndendo momentum yake so ikurani. Momentum yake so ikusintha. Furuma kawa pangapo increase chani velocity. So because impulse produces a change in momentum, tunena nzo kuti topano impulse is equal to change in momentum. Impulse uja force times time uja ft uja ndi chimodzimodzi momentum, change in momentum. So it's like in the musimu tabwera kuti ft is equal to uyo chizindikiro cho cha ethape chosintha mv ndi mass times velocity imene momentum. Now we are saying is equal to ft uja is equal to mv minus mu, where mv is the final momentum and mu is the initial momentum. mv imayimira momentum yakumalero, mu imayimira momentum imene ili yokoyambirira, object imene ali nayo yokoyambirira. So we are saying impulse helps one to understand the law of conservation of momentum. This means kufunika muzivetsetse. Tikamaza panga law of conservation of momentum, tizafunika tiziza kumbukira so za impulse. Chifukwa impulse ndi mema pangiso kuti tivetsetse bwino. Tukupitiliza. Example, a hammer strikes a metal rod with a force of 20 newton. If the impulse lasts 0.4 seconds, calculate the impulse due to this force. So it's a straightforward. Tufunika kuti ngokumbukira unezo kuti impulse imapezedwa morani. So solution, we are saying impulse is equal to force times time, as we discussed earlier. Ndetu force yathu apapo ndi 20 neuron pamene time yathu ndi 0.4 second. Tikapanga times impulse yathu tupeza 80 neuron second. Now let's discuss neuron's second law of motion. Titakambirana za neuron's first law of motion, now tikambirana za neuron's second law of motion. So this states that the rate of change of momentum is directly proportional to the resultant force, and it takes place in the direction in which the force acts. Now here neuron's second law of motion imagamba za rate of change of momentum ndi resultant force. If the rate of change of momentum is increasing, the resultant force will also what? Increase. Zimene nthawi zoti kusintha kwa momentum pa kanthawi ina yake kumakhala kuli directly proportional ndi force yake imene kuyambitsa kusintha. So we are saying force is directly proportional to change of momentum, only we are using a symbol kamene kaoneka ngati a ndi ka symbol ka directly proportional. So change in momentum over time taken. Now force is directly proportional to final momentum minus initial momentum over time taken. Time taken, we are including time taken chifukwa choti pali rate imakhala kukamba za nthawi. To continue, we are saying initial momentum is equal to mass times initial velocity. Initial momentum ndio imakhala pangidwapo mass times initial velocity. Initial velocity ndio ndi velocity imene chinthu chimanyamukira. Komano initial momentum imayimidwa ndi mu. Komano opposite nayo ka mv, it should be mu. Pamene final momentum is equal to mass times final velocity, imene imayimidwa ndi chani? Ndi mv. Now change in momentum. Tukupitiriza ponezo change in momentum is equal to mv minus mu. Zinthu apapa zikusintha. mv ndi ngati final momentum, mu initial momentum. Rate of change of momentum, now rate of change of momentum ndo ndi mv minus mu uja kugawitsana ndi time ndi 5 kwera over t. So tikozo panga factorize m, pamene kapanga factorize m ndo likhala m open bracket v minus u close bracket over t. Tunezo di but v minus u over t is equal to a, where a is a acceleration. Tikafuna peza acceleration timapanga final velocity minus initial velocity over time. Ndi imene ili apo. That's why talemba noti komano v minus u over t ndi chimodzimodzi a. Ndengati v minus u over t ili chimodzimodzi a. Ndoti apo kuti khoka panga substitute ndoti zabwera uzaneza kuti izakhala noti therefore force is equal to mass times acceleration. This is a mathematical expression of the second neuron's law of motion. Why is this a mathematical second law of motion? Chifukwa noti ikukamba za resultant force komanso ikukamba za change in what? Change in momentum. Change in momentum yathu apopo ikuyimiridwa ndi ma, pamene resultant force ikuyimiridwa ndi f. We got an example. A truck of mass 2.5 tons accelerates at 5 meters per second square. Calculate the force generated by the truck's engine to attain this acceleration. Now here, tufunika tikumbukira formula ya force is equal to ma. You can pause the video and try to solve the problem. Kuti mupange compare ndi answer imene neyo nditapeze. So we are saying force is equal to mass times acceleration. Now here ndo tingopanga chani? Tingopanga substitute. Mass tiyene yali sinthe tipange convert matanzi apite ma kg. Chifukwa apo tapanga times 1000 kg. Tikapanga times answer lathu tupeza ndi 18750 newtons. That's our answer from that problem. So is straightforward. Chifukwa tangopanga substitute potengera formula yathu ya f is equal to ma. Kupitiliza, we got example number 2, which is calculate the acceleration produced by force 20 neuron on an object of mass 300 kg. So here tukufunsira noti peza acceleration. So tifunika tipange substitute formula a. Kupanga substitute formula a ndoti a is equal to force over m. Chifukwa pa f is equal to ma tingogawa mbali zonse ndi m. Imeza khala acceleration is equal to force over mass. Tikapanga substitute force yathu 20 neuron kugawita ndi 300 kg, answer yathu tupeza ndi 0.0667 meters per second square. That's our acceleration. Thank you for paying attention for this lesson, that is Newton's laws of motion. We'll continue in another in another video that will take Newton's third law of motion and the law of conservation of momentum. Thank you.